Good afternoon. Welcome to NIS webinar. Thank you for joining us. My name is George Diloyan. I am CEO of Nanotech Industrial Solutions. And on today's seminar, we're going to be talking about unique IF-WS2 particles. We will talk about the size, the shape, how it is important, where it is used, what is IF-WS2 stands for. So it's going to be more high-level first seminar on IF-WS2 technology, so you can find and understand the basics of it. And it's the first seminar of the series. We're also going to be talking about molybdenum disulfide and graphite and other solid particles and what the difference in comparison with IF-WS2. So for any questions you might have during my presentation, please go to Q&A section. The chat is disabled because it's getting too busy. So if you have any question, please leave it in Q&A section of this webinar. What is IF-WS2 and what is nanotechnology in general? So size is very important in these applications, and the smaller the particles, the more surface areas they can take and they can be distributed on. So nanotechnology in general is just a broad name for technology and all the space without even mentioning what type of chemistry. However, chemistry and shape is very important. So don't get really excited when somebody talks about nanotechnology in general. Please always ask the question, what is the chemistry? What is the geometry? And that's very important because nano, it just means size. So nothing more than that. So fullerenes being discovered back in 1986 by international team of scientists that got a Nobel Prize for this technology in 1996. And in between of these two very important dates, in 1992, Professor Rashid Tana from Weizmann Institute of Technology in Israel discovered that a spherical shape of particles can be made not only for carbon material, but also for inorganic matters, something like tungsten disulfide or molybdenum disulfide. So what does IF stands for? I is inorganic and F is fullerene-like, because fullerenes and the terminology fullerene or bucketball, they're all primarily are used for carbon-based materials, like C60 as an example. And WS2 stands for tungsten, and S2 is a disulfide, so it's 2 sulfur. So inorganic means that it's material. It has primarily, most of inorganic materials have a high melting point. They don't degrade. They're not biodegradable. So one of the examples could be salt. It can be biodegradable. It's environmentally friendly, could be, but it doesn't mean it's biodegradable. So there's two terms of biodegradability and environmental friendliness. They shouldn't be always together. So tungsten disulfide that you see from this slide, you can see the periodic table. You can find tungsten, which is W or wolfram, and sulfur is S. Onion-like structure also is used for describing tungsten disulfide fullerene-like particles because of the multi-layer and spherical shape of it. And we're going to be talking a lot about shape and importance of shape, importance of the multi-layer structure, importance of the hollow core, importance of the size. And in more seminars, you're going to see where the applications are, how it is used, and all those particles, what performance they are getting due to its shape, chemistry, and size. Again, all three parts of this phrase are very important. So there's a video on YouTube, and we're going to be sharing with you the screen and link of this video, where it shows how IF-WS2 works. It's a very exciting video that's been made from the from the transmission electron microscopy and compression of the particles in TEM, and it shows basically how particles work, how elastic it is, how exfoliation of the layers occurs, and how particles get back to near to its original shape. So if we're gonna talk more about small particles or size, as I mentioned in the very beginning, the size basically refers to surface area. The smaller the size, the more surface area those particles can basically take. And thus, the more surface areas they can take with the same amount of material, active material, you can cover more area, or if the area is constant, you can use less of the active material to do the same job. So you can save the cost. And when you exfoliate the particles, you're reducing the friction. So reduction of friction is basically reducing the operating temperature. It's also gonna influence on wear metals and the wear in general, and it's gonna give you a longer life of the equipment, longer life of the lubricant, and overall reduction of the cost of ownership. As I mentioned in a previous slide, and again, video will be distributed to each of you, due to particles' shape and geometry, because the particles are spherical, they can play a role of the nanoball bearings. So they can roll between the surfaces. But the very important point of these particles is that they have a very high impact resistance or extreme pressure, but extreme pressure has 2 points. And one is dynamic and another one is static. So not only can withstand the very high pressure, contact pressure, it also can withstand the shock. And shock is very important in many industrial applications because if they can absorb the shock due to the shape and a hollow core, they can absorb the shock and reduce impact on the surface. So reduce impacts and reduce micropitting and microcrack propagation on the surface. On this slide, you can see the comparison of tungsten disulfide to molybdenum disulfide. So you can see that both particles are gray in color. They both are inert and non-toxic. However, molecular weight of tungsten disulfide is higher than molybdenum disulfide. Also, tungsten disulfide can operate under more broader temperature. Coefficient of friction is significantly lower compared to molybdenum disulfide, and the load bearing capacity for tungsten disulfide is much higher than molybdenum disulfide, as well as the melting point for tungsten disulfide is higher. So both molybdenum disulfide and tungsten disulfide, known for industries including lubrication and coating for many years. There is no news that tungsten disulfide and molybdenum disulfides are considered to be one of the most lubricious solids on Earth for many years. There is no news in that, that's very well known. But we at Nanotech Industrial Solutions created a new generation of tungsten disulfide, which we call IF-WS2, which gives much better performance, which gives more benefits to lubricant, coating, and polymer manufacturers and end users. So you compare conventional molybdenum disulfide or tungsten disulfide with IF-WS2. You can see on this slide there are two sides. So on the left side, you can see how molybdenum disulfide or tungsten disulfide, they look very similar. So the platelet type particles, they're quite large in size, above 1 micron up to 3 microns, and they have multi-layer structure. They do demonstrate a very good performance if IF-WS2 would not be there. So again, as I mentioned in the previous slide, the tungsten disulfide and molybdenum disulfide known as one of the best lubricants, solid lubricants. However, when IF-WS2 is compared to a regular legacy type of molybdenum disulfide or tungsten disulfide, IF-WS2 outperform both drastically. Because of platelet type of structure, when there's shock occurs in the application, they transfer shock to the metal surface and do not protect from micropitting and microcrack. There are also a lot of limited areas of applications, primarily in greases, in coatings, and some in polymers. And it's primarily supplied in a powder form. The required treat rate is 3 to 8%. However, IFWS2, due to its size, the treat rate is much lower, between 0.1 and 2%. They absorb shock, so they create a barrier for shock absorbance and prevent from micropitting and crack propagation. They have very good anti-wear, anti-friction properties, and they have much wider range of applications because IFWS2 is supplied in liquid form, in dispersion form. And I would like to mention is dispersion is not a solution. So this dispersion actually has solid particles in the liquid carrier. It's very cost effective, it's much easier to handle and to use, nothing going to be airborne, so you can use IFWS2 dispersions in much wider range of applications. So generally, how do we produce IFWS2? We do synthesize powder from scratch, so we control the size and shape of the material, of the particles. Then we're taking the powder and we making very stable dispersions. So in various liquids, in oil, in water, and other medias. Could be in alcohols as well. So we do possess both knowledge and experience and know-how of how to produce powder as well, how to produce dispersions. And then those dispersions are used by oil manufacturers, grease manufacturers, coating manufacturers, metalworking fluid manufacturers to make finished lubricants and lubricating fluids or coatings. For the summary, NIS Nanotech Industrial Solutions is the only company in the world that has intellectual properties, IPs and patents and know-how to control shape and size of IFWs to produce them in a commercial scale. We also produce nanotubes of tungsten disulfide and nanorods, and we call them nanologs. They're quite bigger in size. But these are pre-commercial scale production. But fullerene-like tungsten disulfide is commercial production. We're making tens of tons of this material, and we produce 40%, 50%, and 15% solutions, dispersions. I'm sorry, of this material for various applications. So our IFWS2 formulations are used widely in oil formulations like greases, engine oils, chain oils, industrial oils, and water-based formulations, cutting, drilling, fire-resistant lubricants, and coatings. I would like to mention that our water-based dispersions at this moment are giving unmatching results in water. So water-based system with IFWS2 can, in tribological properties, outperform oil. This sounds very exciting, very interesting. So in the next seminars and webinars, we're going to be talking more about water because it's a very revolutionary product. And we're going to be talking about where it can be used, how it can be used, what material it can be applied to. But overall, on a high level, IFWS2 lowers frictions and increase efficiency up to 15%, depending on applications, and decrease wear by up to 37%, thus reducing downtime, lower cost of ownership, and IFWS2 increase EP properties by up to 2.5 times. Which in a heavy-duty application is extremely important because it saves energy as well as it reduces downtimes. So this was a quick introductory seminar about our technology, and we're gonna continue these seminars, continue talking about our technology, and more technical seminars also gonna be released soon, so please stay tuned. I see there are already lots of questions, so thank you very much, they're great questions. We're going to be answering all those questions within the next 24 hours because time is up for this seminar. And for all the questions that we not going to be able to answer at this moment, we're definitely going to get back to you in next 24 hours. So thank you very much for attending. It was a pleasure. Giving such a seminar to you. Please stay tuned for other seminars coming up. Again, as I mentioned, more technical as well as sales related. So what are the best applications, how to tackle those applications, formulation based as well. Seminar are going to be talking about H applications specifically and what our technology can give in those applications. Thank you very much again. Have a great day. Bye.